In this lecture, I would like to discuss C2H point group, that is C type of the point group. When the molecule is having Cn axis of symmetry and n horizontal planes, generally that molecule shows CNH type of the point group. Now the example, it is C2H point group. C2H point group contain a C2 axis, a sigma H plane, and along with it is having the center of symmetry also, center of symmetry I. Molecules belonging to this point group, the example, it is glyoxal, trans dichloroethylene and difluoroethylene molecules. So let us take the example of trans dichloroethylene molecule. So this is the trans dichloroethylene molecule. The two chlorine are on the opposite side of the carbon-carbon double bond system. Similarly, the two hydrogen atoms are on the opposite side of the carbon-carbon double bond system. Now, when we are passing a vertical line to this center, as it is having the center of the symmetry. So let us show here the center of the symmetry in this molecule. So you can see here center of symmetry, and rotating this molecule along the C2 axis. Then suppose we labeled, this is hydrogen 1, this is chlorine 1, this is hydrogen 2 and this is chlorine 2. So rotating along with this, then we are getting the equivalent configuration, and that rotation, it is around 180 degree, rotating this around 180 degree. So this hydrogen comes here, so we can show this in this way. This hydrogen at 1 will be here and hydrogen 2 will be here, then chlorine 1 will be here and chlorine 2 will be here. So it means we are getting the equivalent configuration. Equivalent configuration. So C2 is the principal axis here. Symmetry element is C2, two-fold axis of the symmetry. Now this molecule is having the center of the symmetry I, and along with this center of the symmetry, it is having the horizontal plane of the symmetry. So how there is a horizontal plane of the symmetry? Let us show this. Horizontal plane of the symmetry. So this is hydrogen 1, chlorine 1. Now it is hydrogen 2 and chlorine 2. So it is having the horizontal plane of the symmetry. So when we are passing that horizontal plane through this, what happens? It shows the equivalent orientation. It shows the equivalent orientation, and it will be like this. The equivalent orientation will be like this. Okay. So chlorine 1 will be here, hydrogen 1 will be here. They are coming to the front side, and this is chlorine 2 and hydrogen 2 will be onto the back side. So by passing the horizontal plane of the symmetry through this, that horizontal plane of the symmetry, it is perpendicular to the principal axis. Perpendicular to the principal axis. Then what happens here? It shows such type of the configuration. So it is having the sigma H. Hence, the number of the symmetry elements are existing in this molecule are 3. C2 axis, center of inversion, that is center of symmetry, and horizontal plane of the symmetry. So it means that this molecule is having the point group C2H. This molecule, it is having the point group C2H. So C2H point group is only possible when the molecule must have the C2 principal axis and center of symmetry I and horizontal plane of the symmetry. That molecule should have horizontal plane of the symmetry. Then that horizontal plane is perpendicular to the principal axis. That is the important thing. That horizontal plane, it is the perpendicular to the principal axis. So in this way, in trans dichloroethylene molecule, you can see here the horizontal plane. When the plane is perpendicular to the principal axis, it is called horizontal plane of the symmetry. So this trans dichloroethylene molecule, it is having the horizontal plane of the symmetry. It is having the C2 axis. It is having the center of inversion. So the point group assigned to the molecule, it is C2H point group. It is C2H point group. Okay. So let us discuss the next type of the point group, that is D type of the point group. So when the molecule is having the D type of the point group, if the molecule is having CN axis of symmetry, if the molecule is having CN axis of the symmetry and NC2 perpendicular to this, then it is having DN type of the point group. Now, if the molecule is having CN axis along with NC2 perpendicular to it and horizontal plane of the symmetry sigma h, then the point group assigned to the molecule, it is DNH. That is the another rule. So let us take the example of this DNH type of the point group, that is D3H. So D3H point group has a C3 axis. The principal axis is C3 and it is having 3 C2 axis perpendicular. Then the point group, it is D3 type, and on the same time it is having the vertical mirror plane and horizontal plane. So point group, it is assigned to the molecule according to this sigma h. So the example of the molecule, it is boron trichloride. Example of that molecule, it is a boron trichloride molecule. So let us take this example how that point group, it is possible in the boron trichloride molecule. So let us draw here the structure of boron trichloride molecule. It is having a triangular shape. 3 chlorine atoms are bonded covalently. Suppose this is chlorine 1, chlorine 2 and chlorine 3. Now when we are passing the axis through this central boron atom, then all the 3 chlorine atoms can be rotated. So angle of rotation, it is 120 degree here. So that is, it is having the theta it is equal to 120 degree. So by rotating this, it shows the equivalent configuration that will be like this. So chlorine 1 will be here, chlorine 2 is here and chlorine 3 will be here. So it is having C3 principal axis. Now along with this C3 axis, boron trichloride molecule, it is also having 3 C2 axis. You can see here, it is having 3 C2 axis. That C2 axis, it is passing through the boron and 1 chlorine atom. That C2 axis, it is passing through the boron and 1 chlorine atom. So it can shows the equivalent orientation. C2 means 180 degree rotation. So you can rotate this 180 degree. Then it shows the configuration. Chlorine 1 remains as it and chlorine 2, it is now here and chlorine 3, it is here. So it is having the C2 axis, 3 C2. This is one. Then another we can show here. And this is another one. Now in this case, C3, 3 C2s are perpendicular to C3 or C3 is perpendicular to 3 C2. So the point, when this condition is satisfied, the point group assigned to the molecule, it is D type. So it is D3 type point group. It is D type of the point group assigned to the boron trichloride molecule. Now on the same time, it is also having the 3 vertical mirror planes. Let us show that 3 vertical mirror planes in the boron trichloride molecule. 3 vertical mirror planes. This is chlorine 1, chlorine 2, chlorine 3. Now when we are passing the vertical plane as like of this is the vertical plane through one boron atom and chlorine atom. It shows, means this chlorine 3, it is the mirror image of the chlorine 2. So the configuration can be shown in this way. Chlorine 2 is now here, chlorine 3 is here, and this is remains as it. So this is the one vertical plane. Similarly here we can show another vertical plane here, another vertical plane here. So it is having 3 sigma V. Okay, so it is having 3 sigma V boron trichloride molecule, and another plane of the symmetry it is having, that mirror plane, it is perpendicular to the principal axis. This is C3, it is the principal axis. So that mirror plane, it is perpendicular to the principal axis, that is a horizontal plane of the symmetry. So it is having sigma H. So the number of the symmetry elements in the molecule are C3, 3C2, then 3 sigma V, and sigma H. Identity is always there. So these are the number of the symmetry elements in the molecule. So point group assigned to the molecule, according to this it is D3, and according to this sigma H it is D3H. So boron trichloride molecule, it is having the point group D3H. Okay, point group assigned to the boron trichloride molecule, it is D3H point group. So in this way we explain the D type of the point group in the boron trichloride molecule.